Hello and welcome back. We're now in session 7. We've come quite a long way. And in this session, we're going to get into customizing your applications via SensorApps. So it is entirely possible to create your own apps similarly to in an app store, to make an app yourself, put it into your sensor, and have that solve a very specific task that you need to have be done correctly. I have Timo Mendla here with me. Hi, Timo. Strategic Product Manager for AppSpace.
Pleasure.
And he's going to take us on the ride of SensorApps with the help of Velux, with Lasse coming back again. I'll be looking forward to seeing him again. Take it away, Timo.
Thank you very much, Patrick, for this introduction. My colleague Christoph and also Lasse from Velux, happy to have you here today, already teased this topic a little bit. So it's important to be able to tell for example, the defective parts from the good parts. But that's not the only thing about a sensor application. There's a lot more around solving the actual problem, like data acquisition, the processing of the data, and also the shipment of the information and the presentation on a user interface. And this is why it's today my privilege to present to you a short introduction to the SICK AppSpace ecosystem along a couple of application examples that completes these tasks. So, like before, we'll start with a short introduction video. AppSpace is the idea of transferring AppSpace is the idea of apps transferred to industrial sensors. So let me start with just highlighting again that there are already ways to do it today, to do, for example, the machine learning, but to do all the stuff around it. And actually, most of what you saw was implemented using AppSpace from the previous presentation. So let's get into a short example here. We have a food inspection task where we want to check for contamination, and we're going to be using machine learning for that, contamination of cornflakes, for example, with foreign objects, with packaging materials, and so on. We have a small demo here that I will take you through. So first of all, every AppSpace device has a web server that displays the web-based user interface of the particular sensor app. This one allows us to configure the image acquisition settings and already take snapshots, which we can later use to train a neural network, for example. So this is an example of clean cornflakes, let's say, and then we could have a contamination here with a piece of cardboard from a cornflakes box. You can directly do the segmentation, also like what Lasse described here, and you can even run the automatic data acquisition and have it shipped from the sensor app directly to an FTP server on your computer. So once you have generated your training data, what you could do then within this app, or you could jump to the DStudio toolchain that Christoph described and that Lasse also showed and used. And once you have retrieved your network, you can upload that trained network into the app, into the sensor directly. You can use your own model coming from the DStudio toolchain, and then you could perform the inference on these images that you acquire. So in this case, it's all OK. If we have the cardboard piece in there again, it will detect this contamination. And even if we have other parts like a semi-transparent wrapper here, which might not even have been in the training set, it will still be able to reliably detect these contaminations. So now we switch gears a little bit and show you how that solution is created. This, what you see here, is our SICK App Studio integrated development environment. And I'm connected to the sensor here, and I'm loading the app directly from the sensor into my workspace. Now I could, for example, open a piece of source code where the neural network is actually being used. So here you can see how the deep learning API is being used. The documentation comes right with the device and with the sensor that you're connected to, so you can always be sure that what you're using is what you think you're using. And even the user interface, as I said before, is part of the sensor application. So that is a web page. Here we have a kind of structural view now of the data acquisition page. If you remember, there was a little camera ready indicator traffic light at the top. And that if you wanted to, for example, change that into a checkbox now, all you would have to do is select the checkbox from the selection of user interface elements on the left, drag it to the user interface, and connect it to the right functions in the source code. So that's it about the video, or about the demonstration now. So let me explain a little bit more about the surrounding of this AppSpace ecosystem. At SICK, we're all about solving sensor applications. And I'm not telling you anything new if I say that these are becoming more diverse, more complex, require more customization, and increased usability by all. So we have the rise of machine learning, which generates vast amounts of data. Automation is becoming more prevalent in all aspects of our lives. Here, as an example, the distance checks between persons in a bar, maybe to comply with some corona guidelines. And also the user interface, the usability for the user. We're used to very comfortable work on our mobile phones, and this also translates into our industrial sphere. So how do we tackle this? How do we get this super big Swiss Army knife? How do we that we would need to solve all these problems in a good way? How do we get this? And our answer at SICK is not really to provide the big army knife, which has all the functions but doesn't fit in your pocket, but to provide you the SICK AppSpace ecosystem, an engineering framework for your sensor applications. And it stretches across all types of applications, all technologies supported within one ecosystem. So take the example of a mobile phone again. I value my mobile phone because on my way to work I can listen to podcasts. My wife likes to play online poker, so she values her phone, which is exactly the same model as mine, for very different reasons. And the apps is what making that happen. So take that to the industrial application domain, where we have 6 layers: the hardware, the operating system, algorithms and services, application logic, configuration, and user interface. With AppSpace, we separate the 3 application-specific layers out, and we bundle this into the sensor app. And we allow anyone, people at SICK or people in our developer partner network, to develop these apps and to solve applications in a good and customized way, including the results that you saw for deep learning and other topics. So we all know that software developers don't grow on trees, and so we have a whole ecosystem and community around these sensor apps. On the left side, you see that we maintain this community through regular conferences, as well as through our support portal and the interactions there. We have a dedicated set of tools for developing, deploying, and presenting these apps. I will show a couple in a minute. And also, of course, and at the focus, are the programmable devices, the hardware. There's already now an extensive and even further growing portfolio of devices that are programmable with all these exact same tools. The sensor integration machines, 3D vision, 2D vision, LiDAR technology, multi-layer and single layer, as well as RFID and display technology. And also newly and importantly, there's a PC software that you can install on an industrial PC, which you may have already running, and it will turn that PC additionally into a programmable AppSpace device that can take SensorApps and solve sensor applications using the powerful APIs already present. A couple of application examples really quickly. One of our integration partners has programmed a programmable camera here with a sensor app to integrate with a robot arm that tests white goods. It makes the position correct of the robot, of the test finger, and also identifies the panel that is being used. OK. A label checking. If you have a label checking task, you can use the label checking app from our developed in our Czech subsidiary, which is easy to set up and can inspect all kinds of label print products. Another integration partner, Imation, they have worked out a way that you can upload a DXF file. So from a technical drawing, a CAD software produces DXF files. You upload them, and the camera will start detecting exactly that workpiece, even if it has not been programmed exactly for that, and detect it and position it, and also communicate this information through various channels. And that's also available for download through our SICK app pool. And then last but not least, or another example actually from many, is from our partner Autocoding Systems, an app that allows you to inspect use-by dates on food packaging. Now, without any further ado, you don't have to take all of this from me, because we have still Lasse on the call. So I will take it from here. Sorry, he will take it from here. Lasse, the stage is yours.
Thank you, Timo. And once again, thank you to you that I can be part of this. And I'll just start sharing here and full screen. So the SICK AppSpace was a product that we, in our department where I work at, adapted as early as 2017, one of the early adapters. And the reason for that, I will try to give a little explanation about here, because we are not a machine builder in that term that we build for other companies. We are both internal machine building and OEM end user of the product. So our current state in Velux, as you can say, and that is still the case, is that the vision system that we have are custom solutions. A lot of vision systems built on different programming languages, C, C++, C#, Python, etc., and running on different hardware, both camera-wise and also industrial PC-wise. These are really flexible. In some cases, it's also cheap hardware. But the solutions also lacks the transparency in the terms that it is compiled languages, or the vendor or the programmer is often sitting on the license of the code. So the solution in many cases lives as long as the person who has made it lives. Then we also in Velux are using smart cameras, smart camera sensors from different suppliers. These camera sensors are, of course, intuitive. They are configurable, and that is a good thing if you are a non-programmer, if you are a technician doing something fast. But it's also fixed in tool sets, so we need to wait until SICK or other suppliers develop the tools that we need, and then it is locked to that specific task. So in order to try to work around these or to mitigate these issues with the solutions, we saw that AppSpace could actually fulfill the state that we would like to come into, where we can standardize and harmonize our machine vision landscape in Velux in the same way as we do in our machine building when it comes to PLCs and HMI panels, where we have both code standards and we have component standards and etc. So the standardization, the standardized solution for a company like Velux, AppSpace fulfills that by providing a framework off the shelf, so we don't have to either buy it elsewhere or to develop one ourselves, all the tools that we need for both machine vision, but also for other integration part in the Industry 4.0 terms. We have all the integration possibilities with this AppSpace, and we have blob tools, edge finding, and all these amazing features that we can use instead of building it on our own. That makes the possibility that we can do reusability of code and solution, because AppSpace, as I have tried to explain it, I look at it as a little bit like a PLC. If you know a PLC brand, you can always find a PLC programmer to help you with it. In the same way, if you say it's in AppSpace, you can find a programmer that is known to AppSpace, and he will do less engineering by using the framework. That means also faster time to market. And when we say that in Velux, it also comes into all the machines that we have to build for new products, because 95% of our machinery is specialized, special built machinery. And then from one of the benefits, it still runs on different hardware. Of course, it's SICK hardware, but now the opportunity to actually install the AppSpace framework on a industrial PC makes it even more flexible in the terms of hardware if we need more power than SICK can provide. And then, of course, the most important part is that from the Velux company, we are in control. The investment security is higher because we own the code. We want to have the code on the device without know-how protection. So if the company that has helped us develop it either goes into bankruptcy or in a disagreement, we still have the investment security of our solution. So by that, we have begin to make our own AppSpace template to be used in our production. It's a common code library that we would like to use across Velux sites and Velux project. That is give us the benefits of course, more efficient sharing of specialist resources. That's both internally, but of course also external companies we can partner up with. And the know-how is a share between external and internal specialists, which gives us the investment security. And it also gives more transparency because the solutions do not follow the program. Then again, also it has a faster implementation and troubleshooting because many functions can be reused from project to project. The user interface, the viewer part to present what is happening on a, for instance, a vision application is pre-built with pre-functions, so it looks the same, and the operators then get the same look and feel, even though they are shifted between different machines and different locations, different factories. That gives a huge benefit in the current situation where many uneducated people working in factories are actually working there for a short period of time to gain some money and then go on again. So we have a faster shift in employees in our production, and the future is only increasing that as we see it, which means that we need to have our machines to be more intuitive and more intelligent. An example of the implementation, I'm a programmer myself from the PLC and the automation world. I have no prior programming knowledge with machine vision, only smart vision sensors, the configurable ones. But when I saw AppSpace, at least for myself, I can say that it took me really little effort to learn the programming language that is used, the Lua code, which is a scripting code based on C, but the programming language is really easy, and the App Studio IDE editor is also really helpful to work with. And a huge benefit in that is also that it has the built-in emulator. So even though I'm just having some images, I can work with it offline on my computer, making it fast and easy to do some trials. And of course, when it's programmable, it gives me all the flexibility to create a custom solution, but in a standardized way. And to show an example on that, I have this example here. This is a plastic cover for a remote control for our Windows in Velux. And this has to be picked from a cardboard box and fit into the automatic assembly line. And the orientation in the box, that can vary in all 4 directions. So we need to first figure out the orientation, and we also need to check if the battery clips are mounted from the manufacturer of these subcomponents. This is done in an AppSpace vision system that is solving this task and 4 other tasks. So we don't have a dedicated vision system for this. We have a shared vision system. So the same camera and the same processing hardware can do different tasks because we have made different apps that can be triggered on the device. And for that, I have a small video how to demonstrate on how we have solved this, if you can play that. Yes, so here you see that we have implemented a quick trial where I was in the production and within 15 minutes collected some images from the production line with the actual hardware. And then I am emulating it on my PC now during development to test the solution before it goes into production. And this has significantly improved and sped up, accelerated the development process because I'm not dependent on getting access to our production. And in the future, at least in Velux, as we see it right now, it will be even more difficult to actually get access to physical production environments, so more virtual commissioning, which this also benefits from. And the flexibility, again, by having the possibility to create our own apps, makes it possible to create these hardware solutions that can be shared for different tasks along the machine. And that was my presentation on how we have adapted and are trying to use AppSpace in Velux as an end user of this system, not as an app provider.
Okay, thank you very much, Lasse. So I think amazing show, and
Yeah.
Patrick is with us again. Yeah,
Really amazing. Lasse, we're still just selling you 1 camera.
That's not entirely true.
Okay. No, but I think it's wonderful. You showed it very clearly how you're putting these custom-made apps that you guys have with your IP, putting them into your into the cameras that we are giving to you, and really getting a lot of benefit out of this, and reusability. I thought it was fantastically presented. I understood it. I might not be able to program it in Lua at the moment, but it looks like it's a pretty clear programming language based on C. I have a question from the audience. Are there any restrictions or limitations to create an app development ecosystems in other parts of the world, or are we just limited to the EU for now?
so sorry.
Is it just EU that you can make SensorApps with?
No, you can do that. Sorry, yeah. We sell AppSpace globally in all our subsidiaries, so all the programmable devices are available. To become a developer, if you're working at SICK, send me an email. If you're working outside SICK, if you're a customer, you can join the SICK AppSpace Developers Club, and that is also possible globally. So no restrictions to
Great.
create your
Okay,
own
we won't
apps.
limit. You're keeping the Americans out of the European
They're
soccer
pretty strong,
competition,
actually, yeah.
but in this case with SensorApps, it's not. So we have another question. What are the deep learning algorithms that AppSpace supports?
So I would have to. That's a question I think that Christoph could better answer. But from the point of view of the AppSpace ecosystem, we support the always the newest version of the deep learning API that is used in our solutions, that Lasse uses in his solutions. So if we make an advancement to our deep learning functions, it will automatically percolate. It will come into all the firmwares of all the AppSpace devices where it makes sense to have deep learning.
You put it very well. It's a great word. It's percolating.
We're working on it, continuously expanding, and that is always pushed into all the devices with the firmware.
Great, thank you. And I think we have time just for maybe 30 seconds because we have a lot of questions on this. I like all of the interest. It is, is this what sensor apps are already available?
Okay, so there are a lot of sensor apps that maybe I don't know about because we don't look into the device once it is arrived at the customer. And Lasse's apps, for example, I mean, I'm sure he has these. But the public available apps are, for example, visible in the SICK app pool at apppool.cloud.sick.com. There are about 50 apps public, and I know that there are a number of apps also shared only with selected user groups by persons maybe who only want to make that app available to a couple of people. And also from external parties. For example, the one I mentioned before from Imation GmbH, who have this CAD app as a demo version available in the app pool.
Very good. Well, thank you very much. Thank you for all the interest out there. And a special thanks to Lasse, as usual. Thank you for joining. I hope you're with us again in our next digital event. Very convincing arguments. And thank you, Timo, for joining and explaining the background to AppSpace and the ecosystem.
Thank you.
Join us in a few minutes. We're going to be going into a safety session, so stay tuned.